Hello everyone. I hope you are all doing well. We are here for another weekly session, a new week and a new great session this week. We have a great speaker that have been speaking and sharing his knowledge to us and to other several community groups. And as usual, what I say is if you have any questions, feel free to use the chat to share your questions. And let's try to get the best and the most from this session. Without further ado, I will introduce Eugene. Hi, Eugene, how are you doing?
Hey, Hugo, I'm doing good. Thank you very much.
Always a pleasure to have you here. It's not your first time, so you know already the model of lunch and learn. I hope you have your lunch ready. I don't have yet mine, to be honest, but I hope to have soon my lunch ready. So
In my
we can.
case, I think I will eat after this. I don't think an hour of me eating on screen will be fun for anyone.
Could be different, you know what I mean? Why not? So, as always, thank you very much for your contribution here and your availability to be here and share the knowledge with us. And without further ado, I'm going to just hand over. I'm going to enable your screen,
Mhm.
and I will keep for everyone. If you have questions, please use the chat, share your questions there, and we are going to share the questions with the Eugene and address them and enjoy as much as possible. Feel free to also connect in the chat and let us know where are you connecting from. It's always good to know where you are connecting from. So without further ado, the stage is all yours, Eugene. Thank you.
Thank you very much, Hugo. And hey, everyone, thank you for joining my presentation today. We will be speaking today about how to securely consume secrets in Azure Container Apps. So I will do a quick introduction about what these container apps are in case you're not super familiar with them, and also to how or why we should be, or in which way I should say, we should be consuming these secrets so that they are not exposed to people who should not have access to them. And we will run through a demo in which we will see this in action. So hopefully my demo works. It has been working as I've tested it, but you know, these live events always come with some new fun things. So we'll see. We'll get through it together and see what happens. Before I begin, just a quick introduction of myself. I work as a managing cloud advisor at Capgemini. I am based out of Norway currently. I have been in IT for about 17 years, more or less. Currently, I hold the Microsoft MVP award, and this is partly because of all of this sharing of knowledge with the community. And I would say most importantly, I am a guy who hates seeing secrets in code. Now, if you're a developer, you know that this is just something that you shouldn't do, right? Putting your secrets in the code of your application is just a really bad idea. But sometimes things slip by. Maybe we're testing something, or maybe we just don't necessarily know the best way of having an application consume a secret when we are developing it. So this is something that I'm always trying to see, okay, what is the correct way, depending on the type of application and the platform that is running on, what is the correct way of keeping our secrets and our application code separate from each other? So we'll talk a bit more about this. But first of all, let's talk about container instances versus container apps versus Kubernetes. This is a lot of different things here, right? And now you might be thinking, which one is it that we're going to be looking at again? It's container apps. However, if you are using, in this case, of course, this is a service that Azure provides, but there are similar services in other platforms. But if you're using Microsoft Azure as your cloud provider, you might be familiar with these different kinds of resources that you can create within the Azure platform. However, there is a lot of overlap as to what these different resources do, but it is important to understand the difference between them so that we know which one we should choose for our type of application. So on the one, we could draw a spectrum here of let's call it difficulty or complexity. On the one end, we have the container instances. This is a resource that Azure provides that is very easy to use. As a matter of fact, almost all you have to do is to point this container instance to the image of an application that you want to run, and this will spin up and it will run your application for you. It will just give you an endpoint so you can reach your application. However, because they are very easy to use, they are also quite limited. They're okay for running maybe single image applications, but as soon as you want to do something a little bit more complex or play around more with networking, it's not that good for those kind of scenarios. On the other end of the spectrum, we have, of course, Kubernetes. Kubernetes now has been around for some years, and it is a platform that is maybe difficult, especially if you're not familiar with it. If you are starting from zero and want to run containerized applications, Kubernetes will be the most powerful way of doing it, but it will be difficult to get started with it because you need to learn everything about this platform. However, it is very powerful. It is the most powerful way of running your containerized applications. And basically anything you want to do for your app, you should be able to do it with Kubernetes. So now there is, of course, a middle point, and that is the one we are discussing today. That is container apps. Container apps try to find a middle point between being super easy, but also limited, or being very difficult, but at the same time powerful. Container apps give you a lot more control over the way that you are running your application. This means that you will be able to do a lot more things, to maybe run applications that depend on several different images, to do special types of networking, and so on. However, you don't have to think so much about the platform that the application is running on, which, for example, if you were using Kubernetes, you would also have to think about, okay, we have to set up and configure our entire Kubernetes platform. With container apps, a lot of that is abstracted away from you, and just some necessary things are exposed to you so that you can still do a lot of things with it, but without having to maybe have an entire team that is just the ones managing and administrating your Kubernetes platform. So which one should you choose? Is there a correct answer? Well, obviously there isn't, right? There are many different types of applications that can be run, that can be created, different use cases. So really the final decision will come down to the complexity of the project or the application that you are trying to run. Also, how flexible you need this to be. Are you okay with just running your image and just getting an endpoint and using that? Or do you need to be more flexible, again, when it comes to networking, when it comes to intercommunication between services and so on? And finally, too, what is the size of your team? If you're running a full-on Kubernetes platform, chances are you're going to need to have some dedicated resources to be the ones managing and administrating your Kubernetes platform itself. If you are a team of one person, maybe you want to go closer to the other end of the spectrum there, right? And try to find one platform that is a little bit easier to manage and to run day to day. So again, there is no correct answer. However, this should help you get a kind of an idea of what these container apps are. And these container apps, they are the newest thing within this whole spectrum of platforms. Container instances have existed for some years. Kubernetes has existed for over 10 years now. However, container apps are only a couple of years old. They were introduced recently by Microsoft. So it's a kind of new, exciting way of, or a new option of running these applications. So, okay, so having had that little intro to these container apps and what they are, let's talk also for a minute about secrets. What about secrets? Again, if you are a developer, you know that you don't want to have secrets in your code. That is one of the very first things that you learn when you start developing. At the same time, though, most applications will require some sort of secret to be able to run. This could be connection strings. This could be maybe an internal access token to something, some sort of password to something. There's many different things that are values that applications will need, but which should be kept secret, which should not be visible to outside of servers. Sometimes even maybe they don't even need to be visible to the developers themselves. It might be stuff that needs to be kept actually at a very high level of secrecy and only injected into our application at runtime and when it is needed. So because of that, different platforms use different systems for managing secrets and for injecting secrets into applications. In the past, I have done a presentation about how to consume secrets in your Kubernetes instances. And actually, that was the presentation I did at Cloud Lunch and Learn the last time. That was about a year and a half ago. So if you're interested about that, about how to do it in Kubernetes, you could go watch that one. But let's see how we can do this within our container apps. Now, instead of talking about it a lot, I figured it'd be easier to just demonstrate it. So I'm going to build a very small container app, and I'm going to show you how it is that we can inject secrets into our container app. So let's build this, and let me show you at a very high level what the basic building blocks of our container app will be. In this diagram, if we start from the outside in, you will see the first thing is an Azure resource group. That is the dotted orange line. So we're going to create an Azure resource group. If you're at all familiar with Azure, this is something you need for running any sort of resources within Azure platform itself. So nothing special there. Then inside of this resource group, we are going to create what is called a container app environment. Every container app within Azure needs to be run inside of a container app environment. This environment holds certain values, certain things that are consumed by the container app itself, but that are maybe not part of the app itself. Sometimes these app environments can hold several container apps and so on, right? So we will create this environment, and then inside, and that is the solid red line, the rectangle inside, that will be our container app where we will be performing this consumption of secrets, let's call it. This is what our container app will look like. It's going to be really, really simple. I was trying to find the simplest possible use case that I could use to demonstrate this functionality. So if we start from, let's start from the bottom left. So that's the user. The user is going to interact with a little Nginx server. This Nginx server is just going to provide a static page to the user. That's it. My application is just a tiny Nginx server serving a very, very simple HTML site. This HTML page is going to be created by the init container that you see at the top of my container app here. So what's going to happen is that this init container is going to run first. It's going to create this HTML file, and it's going to put it in a shared folder that the Nginx server is going to pull it from and serve it to the user. So actually, these will be two separate images that I will be running. The init container image is actually, I don't remember what it is. Let me see. Let me check my notes here. Yeah, it's just a BusyBox image. It's just very simple. It's really just doing a cat to a text file in this shared folder. And then, of course, the Nginx one is just an Nginx image, nothing too special, which will take this file, serve it to the user. We're going to create the basic structure first, no secrets, just so that we can see it running. Once it's running, then we will start with the injection of secrets. So let's go ahead and start building this. I got my VS Code here, and I'm going to create everything here from scratch so that you can also follow along and see that there's no black magic or anything else that is needed here. First thing I'm going to do is I'm going to create a file. Do let me know if the text is too small. I'm going to be using VS Code. I'm also going to use a terminal and a browser. So as I switch between them, if the text is too small in any of them, just put a message there in the chat. Either I'll see it or Hugo can yell out at me, and I'll try to increase the size. But I hope that this is good and visible to everyone. So I'm going to choose to build all my stuff here. Side note, strong proponent of infrastructure as code. So I'm going to build everything with Terraform. even if you don't know Terraform, it's very simple to read. So you'll be able to follow along as we create things. I don't think it's going to be anything too complex here that you might not be too familiar with. Terraform can target many different cloud platforms and providers. So the first thing we need to do is we need to tell Terraform which platform it is that we are going to be working with, right? So to do that, we're going to create a main.tf file. And inside my main.tf file, we're going to just declare the provider. I'm going to say we want to use Azure RM. And we are able to pass special features and so on to our provider if we want to. But in this case, we don't need to. All we need is this. That way, Terraform now knows that we are targeting Azure. Another thing I forgot to say, I think at the beginning, Ugo did mention it. If you have any questions, do write them in the chat. There are a few times where we're going to have to wait for a few seconds while something deploys and so on. So I'll try to look at them at that time. But if I don't see them, then at the end, I'll try to just make sure that all the questions are covered. All right, good. So this tells Terraform to target the Azure platform. Let's create a new file. And now we will create our resource group, right? So let's just call it resource_group.tf. And we're going to create a resource. It's going to be of type Azure RM resource group, like that. And we can just, in our Terraform code, we can just call it RG, let's say, for simplicity, right? And what we need here, then, we need to give it a name. Let's call it cloud-launch-learn. All right. And we need to give it a location. Since I'm based in Norway, I will use the Azure data center that is close to me. So I'm going to go ahead and say Norway. I think this has to be capitalized like that, Norway East. So far, nothing special. Let's go ahead and start to, actually, no. Let's also create the app environment first, and then we will deploy those bits while we get into the meat of the demo. So I'm going to create a new file called container app.env.tf. Inside of here, let's create another resource. It's going to be Azure RM container. I like to speak to myself out loud when I'm typing, so I apologize if that gets annoying. Helps my brain think, I think. So let's see, container app environment, that is correct. And we need to give it a few values. So we need to give it a name, first of all. Let's call it secure app environment, for example, since our app is going to be so secure, no secrets in code. We need to give it a location, and we can use the same location as the resource group that we created. So we can just do it like this. And then let's give it a resource group name also, or the name of the resource group that we're going to be storing it in. So we can also use the one we already created. Now we just say .name. And just like that, let's save this file. Okay, so let's do that. Save it. How's this one? There we go. I also really like having my files properly styled. So we're going to create a resource group, and instead of a resource group, we're going to create a container app environment. Very simple. I have a terminal here. This is actually running inside of a little container, but that's besides the point. This is just for the purpose of the demo. At the end, I will share all the files for this demo, and within them, you will find a Docker file to be able to create this little environment here. But it's nothing special. It's just running the Azure CLI. So we can see that one currently is version 2.70, and also is running Terraform, which I believe is, yes, version 1.11. So nothing special. Before this demo, I have run an Azure login command. So in here, I am already logged in to my Azure subscription that I'm going to be deploying all this stuff into. So yeah, a few more things. I have a few aliases set up in here. So you're going to be seeing these commands because I'm too lazy to type them all out. So I have an alias for Terraform init, just TI. I also have an alias for Terraform plan, which is just Terraform plan, do a refresh and spit out an actual plan file. And I also have an alias for apply, which is just apply that plan that was created in the previous step. Okay, so when you see me type, especially TP and TA, is just Terraform plan, Terraform apply. Very good. So let's do a Terraform init. Terraform already now is pulling down what is needed for targeting the Azure platform. That seems to have run well. So let's go ahead and let's use the alias. Let's do a Terraform plan and start to get those resources in place. Very good. So Terraform is already telling me what we're going to do. We're going to create our resource group, and then also we're going to create our app environment. Looks good to me. So let's run a Terraform apply and get those in place. Very good. So while this is running, the next step that we are going to follow is to now create the container app itself. And if you remember, this container app had a init container, a shared folder, and the container itself, the one that will be serving the application, right? Very good. Now let's give this one a minute and hope that it creates. I don't remember how long this takes. I want to say it takes about 45 seconds to a minute to create the app environment. But anyways, while that is running, we can go to my Azure subscription here. Here's my new resource group. So let's head in there right away. And already here, I can see my app environment is being created. Do let me know if this is too small. But if not, if I see no comments about it, I'm going to assume it's the right size. Very good. So I can see now my environment has been created, so we are good to go. So let's keep moving here then. We're not going to need any of these anymore, so we can just close these out. Let's create a new file now for our container app itself. We're going to call it container_app.tf. Very good. And in here, let's create the resource itself. So this is going to be an Azure RM_container app. Within Terraform, we can just call it app. This one is going to need a lot of different values that we're going to be adding to it, right? So starting from the top, we need to give it a name. Let's call it, let's say, secure app, for example. We need to put our container app in an environment. So we're going to put it in the environment that we created in the previous step. So we can just target that directly. That should be this one, container app environment.env, and we need the ID of it. So we're going to target that value. Then we need to put it in a resource group. So let's use the resource group we already created, and we just need the name of it. Then there is a property of these container apps called revision mode, and revision mode means how many different versions of our application should we be running at any one time. There is an option of only ever running the latest version of our application, or there might be a situation where you want to do some sort of A/B testing and so on, where you want to run maybe more than one revision. You can give them a certain weight, et cetera, et cetera. In this case, very simple application. We just want the latest version running at all times. So we're going to say single. Very good. This marks everything in red because it really wants to have this container block. So let's just give it that for now. Is it called no, sorry. There should be a template block. There we go. And within this template block, there has to be a container block. So we'll get to that in a sec, but at least that way it doesn't look as ugly. Very good. Before we work on the template itself, we want to, of course, be able to reach our application. So we need to give it an ingress. Otherwise, this application would only be reachable inside of a virtual network in our Azure environment. But in this case, we want to be able to see it from the internet. So we create an ingress for it. we need to give it some sort of traffic weight, but we'll get to that in a sec. No, it still doesn't take away the red. All right. First of all, do we want to say, should it be enabled from outside? And of course we want that, so we're going to say true. We also need to say which port in our application should this ingress send traffic to. In this case, I know that my specific flavor of the Nginx web server is listening on 8080 by default, so I'm just going to say send traffic to 8080. Now we can give it some traffic weights. In this case, because we have a single revision mode, as mentioned up here, we don't really need to think so much about the weight. We're just sending 100% of all traffic to this one revision. However, it is still a mandatory value, so we still need to add it. So we say percentage 100, and to the latest revision, true. Very good. That takes care of traffic into our application. All right, let's move on then to the template. And the template itself then is how we tell the application what should be running in it, right? Looking back at our diagram here, again, there are three main components: the init container, the container, and then the shared volume in between. Let's create the volume first. So this should just be called volume. We need to give it a name. We can just call it, let's say, dub, for example. And what kind of storage type should it be? If you're familiar with Kubernetes, you know that there are different kinds of storage type. It can just be a directory within the host. It can be maybe some sort of storage from a cloud provider and so on. In this case, because we want to keep it super simple, we're just going to create a little empty directory locally. So we never have to say where this will run, but this will run in whichever host Microsoft is running my container app on. So I never have to think about what that is. This will just create an empty directory that any of my containers can mount. Very good. We got that in place. Let's go ahead then and talk about the init container. Why not? This is the one that is going to create the HTML file that then my Nginx container is going to serve to the user. So we need to give it a name. We can call it, for example, populate HTML, let's say. Let's call it populate because that's the name of the volume. So that's a little bit nicer to me. Doesn't really matter. We need to say which image it should run. So for the purpose of this demo, I want to run BusyBox, and let's just pull the latest version. It worked this morning, so hopefully nothing has changed from 2 hours ago until now. We need to give it some amount of CPU. I want it super small, so 0.25 should be more than enough. We also need to give it some memory. Again, super small is enough, so let's say 0.5 gigabits. Very good. We will need an args or arguments block, but I will not fill that out just yet because that will be, I'll explain in a bit, that will basically be the code of my application. We'll get to that in a sec. So as mentioned, this init container should be mounting the shared volume that we created earlier. So let's see, that will be inside of this block, of course. So we're going to say volume mount. I want you to mount the name, the volume that is called, which we created earlier. And I want you to put it in the following path, let's say /app. That's where it will be in my init container. Let's give this a little bit of space. Very good. So before we do anything more with the init container, let's go ahead and create also the main container, the Nginx one. So let's bring this back up. My container here, we need to give it a name as well. We're going to call it, since the other one was populate, this one can be called serve, Very good. We need to give it an image. As I said, it's going to be running Nginx. However, it's not going to be running the straight up just Nginx image from the Docker Hub because that one is a little too basic. I personally prefer the Bitnami flavor of it just because it has a few more things that can be configured and so on. So it's still basically vanilla Nginx. So yeah, I will use that for this demo. Let's say how much CPU it should have. Since this app is going to be very, very, very small, I'm also going to give it very little resources. So I'm going to do the same as the init one as well. So we give it a 0.5 gigabit and 0.25 CPU. And also, of course, my main running container that will serve my app needs to have access to the same volume. So we are going to tell it to mount the same volume we created earlier, the ..dev one, and on the following path, I know the Bitnami Nginx image by default looks at /app for files to serve. So if I mount it on that /app, I know for sure that my Nginx container is going to find it. All right. So at the most basic, this should already work. We have our Nginx container here, which will run or serve whichever files are put in this shared volume, which files will be created by my init container. So let's get to the actual creation of the files. And within my args block here, this is just a specific thing to the busybox image. Don't think too much about this, but this is how I'm going to be running the cat command inside of my busybox image, right? So the notation for this is pretty horrible, but let's do it like this so it'll be a little bit more readable. So I'm just going to run an sh command, and that sh command is just going to be just a block creating this HTML file, right? So let's do this, and let's do this so it's not super ugly. All right, and within my block here, I'm gonna say I want you to see. I have this written down because this notation is just impossible to remember. Index.html. So I'm saying I want you to cat the following block, the block that I'm going to be creating after this, into a file in /app/ and the file called index.html. Of course, as you know, /app is where we're mounting our volume. So this will create this file in our shared volume. Let's also give it the EOF here so we don't forget it. Good. And now the actual content, what is it that we're going to put in that index.html file? Since, again, it's just going to be HTML, we're just going to create the simplest possible HTML file. Again, this is just for the purpose of showing how we're injecting secrets later, right? So let's create a body. Let's do this. And within our body, this is what we're going to be seeing, right? So let's create a big header, something like this. And we can say not at all secret value. Now, the first thing I'm going to do here is I am going to show how to inject a value from an environment variable. This is important to understand because later on, the way that I'm going to be injecting secrets is also by means of environment variables. So in this case, I'm going to create an environment variable with a non-secret value, and then later we'll have a few with secrets. We'll see how those work as well. So let's create one more here. I still want it to be super humongous so everyone can see it. And the way to inject an environment variable in this case, or to pass it, I should say, to my init container here, we do it like this and like this, I believe. And here is where we'll put the name of the variable itself, right? We can call this one, for example, not secret. Good. What will be the value of this environment variable? This one. well, we need to create it, of course, right? So that we also declare inside of our same block that contains the init container stuff. So let's put it after our volume mounts. So we can just say env. We give it a name. Of course, the name should be the same name we used up here. So not secret. We can just copy that and paste it here. And then we give it a value. We can say the value is very unsafe. All right. So now this will be replaced here. This will be put in our HTML file. Okay, that is a lot of stuff already. So let's try to deploy that. Let me just double check my notes here, make sure I'm not missing anything. Yeah, I guess there's one more thing we could have. At the bottom here, let's create an output so that we can see what the URL of the application is once it is deployed. So we can call it fqdn, and the value should just be something along the lines of, I think it should be HTTPS, and then we replace this bit here. So this will be the container app we are creating. So Azure RM _ container _ app. That's the one we have here. And now you're all defining it. Thank you. So that's my app here, of course. And what we want here is we want to take out from the ingress. And which ingress? Because you can have several. It has to be the very first one. So index 0. And from there, we want the fqdn. I do believe this should work. And this will output in the terminal the URL of our container app. So let's format this. Let's save it. And let's run it. See what happens. Start with doing a plan. Hopefully our Terraform code is correct. It looks like it is. So what will we be making? We will be just adding one thing that is as expected, and it will be my container app here. I do believe the value should be correct. So let's just go ahead and create it. Very good. So this should take probably also about a minute. Once we have this in place, we should be able to get the URL there at the bottom, and then we should be able to just go right ahead and visit the application and just see if we see our HTML there. So, okay, that was actually quite fast. Not too fast, but okay. We got the fqdn down here. Let's save that for a second. Let's just go over here to Azure and make sure we see our application here. Seems to be there. Let's check the revisions and replicas. I do see that it is running, so that is looking good to me. Let's see if we wrote the HTML code correctly. Let's open a new tab over here, paste that there. All right, so far so good. Let me zoom that in a bit. But yeah, as you can see, HTML code, nothing super fancy, nothing super special. But just like that, we already have our container app running. Good. So let's talk secrets now. We have this in place. How do we go ahead and inject a secret? Now, there are two different ways in which you can consume secrets in a container app. I like to say there is the not so good way and then the actual good way. Let's start by showing what the not so good way is, and then we'll move on to showing the, in my opinion, better way. So the not so good way is by creating a secret directly inside of our container environment. That is that little lock, blue lock over here. You can see the secret doesn't live inside of the app, but it lives in the container environment. But our application itself can pull that secret and inject it into the application code. So let's see how that would work. Go back to our application here and remember how we created an environment variable earlier on. So what we're going to do is we're going to create another environment variable right after it. So in the same way, we say env we need to give it a name. Let's call it somewhat underscore secret. But now instead of giving it a value, what we're going to do is we're going to point it to a secret. I'll show in a second what that means. But let's say we haven't created a secret yet, so there's no name for it yet, but let's just give it any name, right? Let's say this is the stored secret, for example. So how do we create the secret now? Outside of our template, is it outside of our template? Let me double check here. Yeah. No, this is actually still inside our template. Hard to tell sometimes where the curly braces end. Okay, so that one is purple. Yeah, it is outside of our template, which makes sense. So in here, we should be able to create a secret. It's good that it auto-completes. That tells me that this is indeed the correct location. So creating our secret, let's give it a name. And of course, we already agreed on a name here. So stored secret, stored-secret. And here is where we give it a value. Now, I already know what you're thinking. What difference does this make? It's still in the infrastructure code. However, we'll talk about that in a second. The value can be, this is not in the app code. So there is already an important distinction here, that this secret is indeed, in this case, it is indeed in our infrastructure code. However, it is not in our application code. If you remember, our application code really is this. We are taking our secret that is outside of a code, and we're going to be, outside of our application code, and we're going to be injecting it into our application. This value, of course, could be injected from a pipeline. It could be injected in some other way. If you create it through the portal, you can put it directly in the portal and then inject it into your application. So it doesn't even need to be in your infrastructure code, although, that already puts you in a position where you have stuff, some in one place, some in another, so it's not so great. But anyways, this shows you how you can hold a secret that is outside, and I will show in a second how that looks in the portal as well, and then inject the secret into your app. So let's go ahead and do that. Since it's already being pulled by this environment variable, we consume it in the exact same way as the previous one. Let's make a little break here. I'll just copy these two. It's a bit easier for myself. But now you understand why I say it's a somewhat secret value, because it's secret in that it's not here. And it's not a direct environment variable, but it could still easily be visible somewhere, right? But regardless, that is one of the two ways of consuming secrets, so we will show it anyways. All right, so let me see if we got this right. We are consuming our environment variable here. We are creating it here. And this is pulling from this secret here. Correct. I haven't tested this. I think you should maybe even be able to omit this block entirely, and the rest should still work if you create the secret itself in the Azure portal, but that is outside of the scope of this demo. Okay, let's format it. Let's save it. Let's run it. See what that looks like. All right, so I can see my container app is now being changed. My environment variable is being added. You can see the secret is being added, but at least Terraform is treating it as sensitive, so at least it's not outputting here. Again, you could inject this through a pipeline somewhere, or in some other way if you have a way of automatically injecting values into your Terraform code before you deploy your Terraform code. And then that environment variable is being consumed here. So let's make sure this works. Let's do a Terraform apply. And hopefully we will get the changes in our application soon. It shouldn't take too long either, since it only took about 20 seconds to create the container app itself. So hopefully this doesn't take too long. Let's see. Yeah, there we go. Let's go ahead and look at, before we do anything with the app, let's look at the app in the Azure portal here. So if we check the revisions and replicas, we see this one was created 7 minutes ago. That's a little too long. Let's do a refresh. There we go. This is now the one we just created. It's already running. The previous one is being deprovisioned. So let's check our application and see if it indeed added the value. There we go. So this is how then we are consuming one of these secrets that are already in our application environment. Where are those, you might ask? If we go back to the portal, you see here under settings, there is a secrets section. And in here, this is the secret that was created. So again, I do believe you should be able to add one through here. And then in your Terraform code, you don't need to declare it. Just then make sure that you do things in the proper order so that Terraform maybe doesn't say like, hey, you're asking me to use a secret, but I can't see that secret anywhere, right? So again, outside of the scope of this demo right now. But as I said, this is what I call the less good method. Let's talk about what I think is the preferred method, which is using a key vault and a key vault secret. If you're familiar with key vaults, you know that they are just a secure storage for secrets. And I think that is the standard, the default way of consuming secrets within applications. So let's see what that would look like. This is what we have so far. What we're going to do is inside of our resource group, but of course, outside of anything that has to do with our container app or app environment, we're going to create a key vault. Within this key vault, outside of this key vault, we are going to create an identity. And this identity is going to have access to the secrets that are in this key vault. Now, by using this identity, our container app can pull secrets that are found in that key vault. And in that way, we don't ever have to, even by mistake, put anything remotely secret into our Terraform code or, of course, our application code. Let's see how that looks like. So the first thing we're going to need then, we're going to have to create a key vault. Let's put that in a new file. Let's call it keyvault.tf. Let's start creating it. So Azure RM underscore key vault. We can just call it internally here KB. So it needs to have a name, and you might know that the name of key vaults has to be globally unique, not just unique to your subscription, but unique to anyone who has key vaults running in Azure. So we can give it a name such as, let's call it secure key vault, and then just some numbers just for some randomness. We need to give it a location as well, of course, so we can use the one from the resource group. We also need to put it in a resource group, so we can use the same. We need to give it some sort of size. The smallest one should work for us. This is the different SKUs that key vaults or that Azure provides for key vaults. We can go with the smallest one, and we need to give it a tenant ID. The tenant ID will tell which tenant to put this key vault into. Easiest way to get this value programmatically, we can create a data block where we see the values of the current client that is running Terraform. Not going to get too much into detail on this, but since the client that is running Terraform is within the same tenant as all these resources, we are able to pull the data from the client info and inject it into other resources when we create them. So this should be called client Azure client config, I believe. And we can just say current, and we don't need to give this anything. Just like that should work. So now here I can just say, go look at that data block we just created, and inside of there, find the value for tenant ID. So this will create my key vault. Now, of course, I need to be able to have some access to the key vault to either add secrets or to read these secrets, right? So the first thing I will do is I will give myself access so that I can create a secret. We're going to say Azure RM underscore key vault access policy. This one will be for me, so I will call it me. Okay, which key vault should it be in? It should be in the one we just created. KV, we need the ID of it. Then the tenant ID should be the same as above. Not really sure why Terraform wants these values every time, but it is there. And the object ID, this is the ID of the identity that is going to be given access to the key vault, right? So in this case, I want it to be me. So actually, this also comes from the client config. In there, now I just want you to look for the object ID. Very good. The reason is because this client that is running Terraform is my same identity. So when I create it in this way, me, myself, will be able to go in the portal and create a secret, okay? Now this access policy, of course, I need to say what should I be able to access. So I want to say within my secrets, I want to be able to, I think I'm going to need 4 things. So let's do this. Okay, I want to be able to get secrets. I want to be able to list secrets. I want to be able to set them, and I want to be able to delete them. Good. Okay, now, how is my container app going to access the secrets? The container app also will need an identity to be able to read secrets, but I don't want it to run it as my own self, so I'm going to create an identity for it. You could ask, why are we not just using a system assigned identity and skip creating a new one? The reason is because you would end up in a chicken and egg problem where the container app needs to be created to create the identity, but then the container app is also being told to pull secrets from a key vault, but then it won't have the policy the first time it runs. And you just end up in a situation where you have circular dependencies, right? And we just create a separate identity, tell the container app to use it. That way we avoid that whole scenario. So let's create Azure RM user assign identity. This one will be for my app, so I can just call it app. Where are you going to be? Same as everything else. This guy, dot location. Yeah. Also, I need to put you in a resource group. Will be the same as this one. Dot name, and of course, I forgot to give it a name. So name will be, let's call it app identity, for example. Now we can give this new identity permissions into our key vault. So Azure RM underscore key vault access policy. This one will be for the app. So same thing. Key vault ID will be this one dot ID. Then the tenant ID, we can actually just copy these from the previous one. Let's copy this whole thing, save ourselves a few seconds here. Paste that there, good. But I don't want this ID to have so many permissions for my secrets. I only really wanted to be able to read any one specific secret I pointed at. So now I just give it get. That way, all I can do is if I say read this one secret, I can read it. It cannot see what else there is in there. It cannot change anything and so on. Very good. Let's save this now then. This should create our key vault and add the necessary, both the identity and the policies for both me and the app. Let's go ahead and run a Terraform plan. Hopefully this doesn't take too long. We only have a few minutes left here, but I think we should be good. Good. Seems like all my stuff will be created. Let's run an apply. While the apply is running, then let's start doing the other bits because I think key vault can take a couple of minutes to be created. So assuming that we have our key vault in place, and what we're going to do later is we're going to add a secret to it manually, right? So that it's completely outside of code. But let's pretend that that secret already exists. Let's pull it into our Terraform run. So we're going to say Azure RM key vault secret as a data block. And we're just going to call it, let's say, app secret, for example. So which secret should it be? Let's say that my secret in my key vault is called app super secret, for example. And which key vault should it be in? Again, the one that we already created, .id. Good. Format that, save that. So that will work once the key vault is in place, which is still creating. Let's now consume the secret in our container app. If we go back to our container app over here, the way we do this is it's actually not so different from the secrets that are directly living inside the container app. But there's a few more things involved. So the first thing we're going to do is we need to tell the container app, here's an identity that you can use to, in this case, read secrets, right? So the kind of identity is going to be user assigned. And the identity ID, this is the one we created in the over in the Key Vault Terraform file. So should be something in here, user assigned identity.app, correct, and we need the ID of it. Good. Then once our app knows about this identity, we can then tell it to pull a secret. So we create another secret block. We still give it a name. We can call it now Key Vault secret. I want you to, instead of giving it a value, I want you to use the identity I just told you about to pull that secret. So that should be the user assigned identity.app.id. And then which secret should you look for? Look for the one that is called, no, not like this. Look for the one from this guy here, Azure Key Vault secret, app secret. That's the one that we told it to read here. So from there, and of course, we need the ID of it. In this case, we're going to use the versionless ID, which will always give me the latest version of the secret in case the secret is updated. Okay, we got that secret in place now for our application. Let's now then create an environment variable that consumes that secret. Let's copy this because this will be the exact same. So this one we could call, for example, super secret. And now the secret name will be the one we created here, which is kv-secret. kv-secret. Good. And now finally, let's consume that within our application. Let's copy this again. Put that down here. Oops. Sorry. The break should have been here. Break. And we can say super secret value. And what do we call it? We call it super underscore secret. Let's just copy this, make sure we get it right. Paste that in there, save it. Okay. Format it, save it, good. Hey, our key vault did not create. Why did it not create? Let's see, creation. Okay, the key vault created, the access policy created. The second access policy, I see. Did I not remove this earlier? Let's find out. Let's go to our key vault and here. And let's go into our access policies. Refresh this. Interesting. Yes, that is me. What is this one then? It seems to be the app one that is, yes, it is the app one that didn't create. So let's do a plan again. Actually, this plan will fail because we haven't created our secret. So let's go ahead and do that, and then we'll figure out the rest. We're going to create the secret, and we said it should be called app super secret. So let's go ahead and create that. And let's give it a value. Create it. Okay, that is in place. Now, what happened here? Yes, of course, it failed because the data block didn't exist yet, but now it should exist, or I should say the secret and the key vault didn't exist. All right, so it's once again, yes, of course. Cool, that is what my mistake was. Copy-paste mistake. When I created this access policy, of course, this is still having the same object ID of myself up here. That's why it's saying, why is there two of us, right? What the object ID should be here is actually the one from this identity we created. There we go. That makes sense. So this should be Azure RM user as an identity dot app, and then from here we want the principal ID. All right, I believe that should work now. So let's do a plan once again. Let's run and apply. And hopefully with this, everything will be in place. So while this is running, talking again about the secrets and the way that they are kept in the container application, just one interesting bit is that if we look at our container app, which is this one, and we look at the secrets section, you see here we got both the secrets we created. The stored secret, if you have the right permissions, you are able to see it here and maybe change it from here. But the secret that is coming from the key vault actually only has the ID of the secret itself. So even here, there's one extra step where the secret is being obfuscated and is not being shown to anyone who has access to click around in here. They would have to have access into the key vault to be able to see the value of the secret. So it looks like this has run, and let's make sure our replicas are in place. I believe this is the one we created just now. So let's go here, refresh it, and there we go. So now we are consuming their secret from our key vault and never seeing it neither in the application code nor in the infrastructure code. Good. So that is basically the demo. We talked about how they look in the Azure portal. So yeah, not much more to say. We are out of time. So start hiding your secrets if you're not doing it already. As you can see, it's really simple to do. You can easily do it just with a key vault. Put your secrets in there, reference them from your code, and you'll be good. And hope you enjoy using these container apps. This is some information here. If you want to see these slides, I got them on my site there. You also can find the repository with all the demo files and that URL there. So I'm not sure if Google will put them later in the description of the video or not, but that's basically it. Thank you very much.
Thank you very much, Eugene. Great session, for sure. A lot of different scripting and Terraform and so on. So
a lot of moving parts, yes.
Yeah. Well, see, this is definitely, I would say, a really great exercise, especially when we are working in an enterprise environments. It's definitely are providing the best practice, which is the way to go. And it's typically based on my experience, it's typically a one-time job. You know what I mean? You just spend some time preparing the templates and then it's copy pasting most of the stuff. And just connecting everything. Yeah.
Correct.
Thank you very much. I don't see any questions. Just in case you have any questions, feel free. We still probably have a minute or two to just get your questions.
And if not, also on my site there that I have on the screen here, I think there's an About Me section where you can find a few other ways of getting in touch. So if there's any questions later, just feel free to send them through there also.
That's the way. Yeah, feel free to connect with Eugene. If you have any questions, just feel free to just share them in the next minutes. Eugene, I just wonder, are you going to be part of the Global Azure?
Yeah.
Of the what, sorry?
Global Azure.
I'm not sure. When is that?
It's in April. May. Now I'm confused. but I think it's actually May. Sorry, May.
Okay. I
Yeah,
might
May.
have it in my calendar. Yes. I
Yeah,
might have it
May
there. I need to double
the
check.
8th, date of to the 10th. So yeah, for everyone, even if you want to attend, Global Azure is coming up, and we are organizing, helping the communities worldwide, organizing events between the 8th and 10th of May to just share about Azure and technology and learn together with everyone. All right, I don't see any questions there in the chat, so thank you very much, Eugene. So there are actually some people that's well, usually watch our contents offline due to time zone difference,
Of course, of course.
so if if there are any questions in the comments of the video, we'll try to forward them to you and ask the people to connect with you as well. All right.
Perfect. Thank you very much.
Perfect. Thank you very much, and wish you a great day, and hope to see you soon. Okay.
You too, Hugo. Bye for now.
Thank you. Bye bye.